Assalamualaikum and hi everyone. We are from Group A. We'll explain about the application of integration revolution of the surface area.
First, the function f(x) equals to x squared is defined. This function represents a parabola that opens upward. Next, the function gx equals to x plus 2 is defined. This is a straight line. To focus only on the required region, both functions are restricted to the interval between 1 and 2. This is done by defining h of x and p of x so that they only exist within that interval. This step ensures that only the portion of each curve between x equals to 1 and x equals to 2 is used. Next, the value of n is adjusted. The slider is increased until n equals to 2 pi, which represents a full rotation around the y-axis. After that, the surfaces are created. The common surface h and y-axis rotates the curve hx around the y-axis, creating the inner surface. Then, surface p and y-axis rotates the second curve, creating the outer surface. With both surfaces visible, the complete solid of revolution is formed. The solid lies between x equals to 1 and x equals to 2, bounded by the two rotated curves. This visual model represents the region used for finding volume using the method of solid of revolution.
Right, Assalamualaikum warahmatullahi wabarakatuh. So today we're going to show you guys about how to use GeoGebra for function 1 minus x squared limit 0 to 1. So first thing first, we write our function fx equals to 1 minus x squared. So next we write function bracket f0 1. So next we select the gx1 and settings, style, line thickness to 3 and color we set to the black. So next we write n. So we settings minimum 1 to 0 and the maximum 1 to 2 pi. So next we write surface g and y axis. So that's how it works. Alright, I think that's all from us. Thank you.
In this video, I will demonstrate how to visualize a surface of revolution using GeoGebra 3D. The given function is y equals to 1 over 5 x cubed for 0 until 2 for the x value, and the curve is revolved about the x-axis. First, I enter the function, which is 1 over 5 x cubed. Next, I will enter the start x value and the end x value, which is 0 to 2. The curve is restricted to the interval from x equals 0 to x equals 2 as stated in the question. Then I create a slider so that we can see the curve and the 3D shape. I will enter the value 0 until 10, and the step is 0.01. As we can see here, the x-axis acts as the axis of rotation. This means the curve will rotate completely around the x-axis. Last, I will type the surface of revolution command and will rotate the view. Where the curve is G, the angle is N, and the line is x-axis. Next, we can move the slider and we can see the curve is revolved 360 degrees about the x-axis. A three-dimensional surface is formed. This surface gradually widens as x increases because the value of y increases more rapidly for larger x. So as I rotate the solid, the shape form is a smooth curved surface that resembles a funnel or a flat horn. It is not a cylinder or a cone because the radius is not constant and the sides are not straight. So that's all.
3D shape in GeoGebra for fourth function. Firstly, type the function into the input box. For this function, fx equal to 3x plus 3. Then press enter. You will see a straight line appears on the graph. Then write gx equal to function and select list of number. Set the value of x from 3 to 0, so only that the part of the line is shown. Next, write n is equal to 1. Then create a slider. And go to the setting and change the minimum to 0 and maximum to 6.28. You can adjust the color if you like. After that, we will turn the graph into a 3D shape. Choose the surface of revolution tools. Then, write down the G, N, and X-axis as the axis of rotation. GeoGebra will rotate the graph around the X-axis and create a 3D solid. Then you can adjust the color if you want to. So this is the result for the area of the function. So you can also drag the screen to rotate the view and see the shape from different angles. This visual helps us understand solid of revolution and integration better.
Okay, today I will do the surface revolution for question 5 using GeoGebra 3D calculator. Y equal to 3 minus x square, but it revolves around y-axis, not x-axis. Open the GeoGebra 3D calculator and type the function fx equal to 3 minus x square, and then press enter. Then we write gx equal to function, and we choose function that has function start x value and end x value. For the function we put f, which means fx. For the start value we put 2, and the end value we put 3. And then press enter. Then we're gonna create if we wanna hide this fx line, we can click on the circle, and we're going to create the slider by pressing N and write 0 for the lower, and for the upper write 2 pi. The step we're using 0.01, and then press enter. And then for surface, you write surface and choose the one with the curve, angle and line. The curve gonna be the gx, and for the angle will be the n, and for the line gonna be the y-axis. And then press enter, and then just click on the play button and you're gonna see the graph. Okay, that's all. Thank you.
That's all from us. Thank you.